Notes for section 4.5 in geometry. We're now going to talk about side angle side. Side angle side. So if you want to again take a look at cheat sheet 6, I've highlighted some key information. Side angle side is indeed abbreviated SAS. But it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of the other triangle, then the triangles are congruent. The angle has got to be between the two sides. So if this is my two sides of my triangle and we say segment AB is congruent to segment XY and the same on the other triangle, this angle that those two sides make at the top have got to be congruent. So my angle here between the two sides, you can see it on that could be my two congruent triangles. The shadow is congruent to the actual object. The angle at the top in between these two sides. We're not talking at all about the two angles at the bottom of the triangle down here. We don't care about that angle or this angle as long as the side, the angle in between, and the other side are congruent to the two sides and the angle in between of the other side of the other triangle, they will be congruent. So let's take a look at this picture. We've got this diagram. Your markings are there. Reminder that the arc marks mean congruent angles. If segment RS, got it, is congruent to segment UV, got it, double tick marks, that's a side. And angle R is congruent to angle U. Remember, we don't have to call it TRS or VUW. Keep it simple. It's the lone angle at that vertex. Angle R is congruent to angle U. There's the angle. The third side has to be segment RT congruent to segment RW. The side and the included angle. What's an easy way to check to see if it's included angle? Trace these two sides. If I trace side RS and I trace side UV or RT, do those two sides that I trace make the angle that's marked? Absolutely they do. Same thing over here. Did side UV and side UW, UV, UW, if you trace those two sides, they actually make the angle that we're looking for. These angles don't count. It cannot be an angle outside of the two sides. So if those three things are true, then the triangles are congruent. Careful of the order again, make sure that it's okay. Side, angle, side. So not much more difficult than side, 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 but we do have to be careful of that included angle. So we're going to practice just naming the included angle. The best way to do it is to trace them. But of course, you only have one piece of paper and not a smart board or dry erase board that every time you trace it, you're going to have to erase it. But if I trace segment AB and segment BC, the included angle between them is right here, angle B. And again, single vertex, it's the only angle that exists down in this corner, so we can call it angle B. Next one, segment AC, use the thick one, segment AC and segment BC, that makes this angle down here in the corner. But be careful, now we can't call it angle C. Cannot name this angle C because I don't know if you mean this angle C or this angle C on the other side. There's two angle C's. So be more careful when you name it, calling it angle ACB. Or of course the reverse order, angle BCA, as long as the vertex is in the middle. Next one, AC. If I took segment AC and traced it with segment BA, okay, it forms this angle at the top. Those two sticks make that angle at the top. I cannot call it angle A. There's too many angle A's up there. There's 1, 2, 3 angle A's. So I'll call it angle BAC, or of course angle CAB. All right, you try these three on your own. pause the video, take a look at this diagram, name the included angle. And then when you come back, check and see if it's right. Okay, you're back. This one should be angle D, and again, just keeping it simple. Second one should be angle CAD, or in reverse, angle DAC. And the third one, angle DCA, or in reverse, angle ACD. Trace the segments, make sure you got those right. More SAS with kind of a proof here. Decide whether the congruent statement is true. Explain your reasoning. Okay, we do have two sides marked congruent. We have side QW congruent to side QP, and if we look here, or not Q, that's a C, QW and CP, yes, they wrote it in the correct order. We do have the other side. So we have side, side. We don't have a third side, so we can't use side, side, side from the previous section. But I bet you we can make those angles congruent. They're not yet. I know you're looking at that like, yeah, they are. They're both 42 degrees. That makes them congruent. They're both 42 degrees, but there are not arc marks on there, meaning congruent. We have to actually say angle W is congruent to angle P, and we need a reason for that. Explain our reason for that. Let's get to cheat sheet 3. You could have just told me, yeah, they have the same measure, so that means they're congruent. That's an actual written out definition. If two angles are congruent, then they have the same measure. But this is an if and only if. We can reverse it. If two angles have the same measure, then they are congruent. So we need definition of congruent. Once we say that these are true by definition of congruent, and again, you're writing out all of definition. If you have definition of congruent, now you can go put your arc marks up there. And double checking that the order is correct, you now know your reason. Those two triangles are congruent by side, angle, side. And again, if you trace your two sides, it should automatically form the correct angle that you're looking for. Let's try the next one. These should look familiar. We did them on a different notes, but with different markings. Triangle TAZ congruent to triangle ZCT. Checking to see if those are congruent triangles. We have a side. We have an angle. Check and see if we have the order correct. Segment TA, segment CZ, TA, CZ, or ZC. They are in the correct order. We have side angle, but we don't have side. We need side, angle, side. If you trace the side that you have, and you trace the angle that you have, it automatically tells you what side you're looking for. I already have this side. I'm forming this angle. When we go both ways, we need this side to be congruent. Can we do that? You betcha. Segment TZ is congruent to segment TZ by the reflexive property. Side, angle, side. And the last one, it says we have one side congruent to another side, and we have an angle, but there's no information given, and there's nothing in the diagram other than the reflexive property down here. And we could say UK segment is congruent to segment UK, or KU, by the reflexive property. But watch this, when I separate out these angles. If I trace the two sides that we just marked congruent, here's a trace, and here's a trace, we get the wrong angle. If you trace the two sides, it has to be the included angle not angle side side or side side angle. We have to have the angle in between. So this one is a no. We can't do it that way. The angle has to be between, and in this case it wasn't. It's not the included angle. So be careful. You can't just say, oh yeah, I have two sides and an angle, so it's side, angle, side. It doesn't work. All right, cheat sheet number 7. If you take a look at that, I'm going to go over it super quickly because we've seen this before. Cheat sheet 7, if two lines are parallel, then corresponding angles are congruent. Then alternate interior angles are congruent, then alternate exteriors are congruent, and then consecutive interior angles are supplementary. So cheat sheet 7 has our corresponding alternate interior, alternate exterior angles. And at the bottom it has a perpendicular transversal. I'm not sure that we ever use that, but it is in this chapter. So I'll let you know if we need it. Cheat sheet 7. So if you had a diagram like this, friendly reminder that those are congruent markings. It doesn't have to say it in a given information. If you have congruent markings, then, or not congruent, parallel markings. If you have parallel markings, then you automatically know the segments are parallel. Name the congruent angles. If I pick angle Q up here, it is congruent way over here to angle U. And you're going to try to figure out why are those congruent. Okay, and if I took this segment or line with this segment or line, tried to ignore TS and just went this way, you might be able to see pretty easily that those are alternate interior angles. Double check your cheat sheet. Make sure you spell it correctly. Make sure you have it all labeled. Alternate interior angles. That's one pair. Another pair, go in the exact opposite direction. You've already picked, and I'll put the markings back on, angle Q and U. How about if you pick angle T and angle R? Angle T is congruent to angle R. Same reason. They are also alternate interior angles. Just going the other way. And right now you might be like, well, so there you go. I've got two parallel lines. I have two pair of alternate interior angles. But you can also list those. Can't call it angle S. You'd have to call it angle QSR, congruent to angle TSU. Vertical angles. They're vertical angles, so it works. Didn't just say name the congruent angles from cheat sheet 7, it just said name the congruent angles. And some of you might be thinking a little ahead of me right now, and you're totally fine. Couldn't I have called those congruent by the third angles theorem? Yeah, you could have. Now that we had those two angles congruent to each other, you could have had these two angles congruent to each other by the third angles theorem. If we listed this first instead of last, you have to use vertical angles if it was the very first thing you listed. So that one works maybe a little bit better. All right, that's it for section 4.5 notes. Do a good job of doing these. Now we know side, 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 and we know side, angle, side, but we still have angle, side, angle, 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 side, and HL to go. So keep up with your homework and keep doing these step by step.